You want proof that we landed on the moon? Okay. You know how I know? Because we took the temperature of the moon, not only the surface, but the interior. And here's how we did it. Would you like to take an interactive virtual tour of this spacecraft, or this spacecraft, or this spacecraft, or even this spacecraft? Well, stay till the end and we'll show you how. In this issue of Spacecraft Guide, we are going to go back to the surface of the moon to debunk some conspiracy theories that we didn't go there, and also to learn about the interior of the moon and what not only is what it's made up of, but how it works. And we're going to use the going to go over the heat flow experiment that was done. And when you click on this, it takes you to the heat flow experiment page. Now, as you can see, this box here is just a central location. The heat flow experiment involved drilling two holes, one 1.6 and the other 2.3 meters. And what they did was the second one confirmed the reading of the first, and what they did is measure the rate at which temperature increases with the depth in a measurement of heat flow from the moon's interior. So how did they do that? What is the principle behind it? Well, if we go into the normal operations, we see heat flows from hot regions to colder regions. The interior moon is compared to the surface with these probes. Therefore, the heat flows from the interior of the surface to where it is lost in space. So with these two probes that are 1.6 and 2.3 meters, you're actually measuring the heat loss between them, and then we can extrapolate from that distance to the center of the moon. Now, the heat is mainly produced by the decay of natural radioactive elements, thorium, uranium, and potassium, raising the heat of the interior of the moon. The heat flow experiment was designed to measure these heat flows from the interior of the moon. Okay, so they did this with on Apollo 15 and 16, and they drilled the two holes and they put the probes in, and then they looked at the rate of the temperature increase with the depth. And what they found out is, okay, this is within that depth, that the surface layer temperature at night is minus 197 degrees Celsius. So you remember that water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. So that tells you how cold it gets at night on the surface of the moon. And it rose to a maximum of 85 degrees Celsius. Again, water boils at 100 degrees Celsius and freezes at 100 Celsius. So that tells you how hot it gets during the day. So the temperature at 1.5 meters under the surface is constant of minus 20 degrees Celsius. So that is below freezing. And it's indicating that regolith, or the soil, is an excellent thermal insulator. So that's what we can use when we go to the moon, go back to the moon, and we want to colonize. So now, as we stated last week, we had the seismic information that was done last month, the magnetometer, which was done last week, and the heat flow experiments, which we're talking about now, contributed to the principal information about the moon's interior and what we believe are the properties of it. Now, if you are a Patreon subscriber, we are going to go over the schematics. And the schematics tells us more about how the probes work, and also why we think, or what prove why we landed on the moon to put these probes in, and that again proving that we landed on the moon, because if we didn't land on the moon, we couldn't have drilled those probes back then, which we have video of. So, for our Patreon subscribers, when you click on schematics, that's all for this week. If you would like to use this interactive virtual reality exhibit on the command module, the lunar module, and the surface of the moon, just go to our Patreon page, and the link will be down below.